Pulse modulation. The process of transmitting signals in the form of pulses, discontinuous signals, by using special techniques. The module includes pulse amplitude modulation, pulse width modulation, pulse position modulation, pulse code modulation. Pulse modulation can be either analog pulse modulation or digital pulse modulation. There are four basic analog pulse modulation: pulse amplitude modulation, pulse width modulation, pulse position modulation, and pulse density modulation. There are two basic digital pulse modulation: pulse code modulation and delta modulation. Pulse amplitude modulation, PAM. The signal is sampled at regular intervals such that each sample is proportional to the amplitude of the signal at that sampling instant. This technique is called sampling. For minimum distortion, the sampling rate should be more than twice the signal frequency. Pulse amplitude modulator. Pulse width modulation, PWM, or PLM, or PDM. In this type, the amplitude is maintained constant, but the duration, or length or width of each pulse is varied in accordance with instantaneous value of the analog signal. The negative side of the signal is brought to the positive side by adding a fixed DC voltage. Pulse position modulation. In this type, the sampled waveform has fixed amplitude and width, whereas the position of each pulse is varied as per instantaneous value of the analog signal. PPM signal is further modification of a PWM signal. It has positive thin pulses, zero time or width, corresponding to the starting edge of a PWM pulse, and negative thin pulses corresponding to the ending edge of a pulse. This wave can be further amended by eliminating the whole positive narrow pulses. The remaining pulse is called clipped PPM. PAM, PWM, and PPM at a glance. Pulse code modulation. Analog signal is converted into digital signal by using a digital code. Analog to digital converter employs two techniques: sampling, the process of generating pulses of zero width and of amplitude equal to the instantaneous amplitude of the analog signal. The No of pulses per second is called sampling rate. Quantization, the process of dividing the maximum value of the analog signal into a fixed No of levels in order to convert the PAM into a binary code. The levels obtained are called quantization levels. A digital signal is described by its bit rate, whereas analog signal is described by its frequency range. Bit rate equals sampling rate times number of bits a sample. Sampling, quantization and coding. Merits of digital communication. Digital signals are very easy to receive. The receiver has to just detect whether the pulse is low or high. AM and FM signals become corrupted over much short distances, as compared to digital signals. In digital signals, the original signal can be reproduced accurately. The signals lose power as they travel, which is called attenuation. When AM and FM signals are amplified, the noise will get amplified. But the digital signals can be cleaned up to restore the quality and amplified by the regenerators. The noise may change the shape of the pulses, but not the pattern of the pulses. AM and FM signals can be received by anyone by suitable receiver. But digital signals can be coded so that only the person who is intended for can receive them. AM and FM transmitters are real-time systems, i.e. they can be received only at the time of transmission. But digital signals can be stored at the receiving end. The digital signals can be stored or used to produce a display on a computer monitor or convert into analog signal to drive a loudspeaker.